Okay, Year 12, the point of this exercise is to determine the correct sample size, or the most effective or cost-effective sample size. Remember, when we want to take surveys, they need to be big enough to be representative, but small enough to be cost-effective, because each survey can be have a cost to it, whether it be in time or money or so on. So you do need to have a population or a sample size that reflects the population, but small enough to be cost effective, and we're going to do it with this activity this morning. So when we look at our textbook, we'll read through the instructions. We'll need to draw up the table, and then we can have an estimate of determining the correct sample size. So the aim of the investigation is to observe how the composition of a sample is affected by the sample size. So you're going to take a large packet of lollies. In this case, I think I've got you some M&Ms as the population. Now, for the diabetics amongst you, you could use coloured discs, or you could just share your jelly beans or lollies with someone else. Now we're going to place the M&Ms in a container and mix well. Well, we're just going to stick it in the middle of our desk and mix it up. Now, without looking, we're going to draw a sample of 10 in such a way that each jelly bean or each sample size, each element or M&M has equal chance of being selected. Now, this can be selected as this is a random sample. Count the number of your selected colour and count to 10. So you might have 4 in your group, each choose a different colour and draw that up in your table. Now, I'm going to return that sample back to the middle of the desk, mixing them well. Then I'm going to select a random sample of 20, and then same number as before, count the proportion of the colour that you choose. Going to continue with this, returning each sample to the container or the middle of the desk, mixing them well, and selecting 10 more each time than the previous selection. Record the number of your colour of M&Ms and put that into the table below. So this is very important that you don't eat any while we're carrying out this experiment or this simulation, because then you would ruin the effectiveness of the experiment. However, at the end of the lesson, I'll let you eat them. So before you get started, you're going to have to draw up a table such as this, and you can have the number of whatever color you want. You can just put up there. Now we're going to enter this data into a spreadsheet, and then we're going to graph the proportion. And this is important because we're going to look at what's called long run proportion, and that's when the line starts to go flat. So knowing that the proportion of your colour in the whole population, that's the final row, represents the true answer. Now comment on the effect of the sample size for the composition of the sample. Now for your experiment, you would have to consider what is the minimum sample size which closely resembles the composition of the population. Now if the sample size is used to predict the composition or characteristics of a population, describe what you feel are the desirable qualities of the sample in order to be a reliable predictor of the composition or the characteristics of the population. Now, you're going to repeat this experiment. That is, each person in your group is going to have a turn at a different colour. And so, remember, to be reliable, it's always good to repeat something 3 times. So, Year 12, here's a sample response that I've had from previous years. And so what you can see is that with a sample size of 10, 4 out of the 10 populations had a certain colour. Now, that's quite high in comparison to taking larger sample size. So that when we had a sample size of 20, we noticed that 4 out of the 20. So in proportion, we had 40% or 0.4 of the proportion being red, and the sample size of 20, we can see that it was closer to 20%. Now, when we went up to a sample size of 30, we went to 23%. So you can see that this is bouncing around, and that's reflected in the graph. So when the graph gets to a straight line or quite flat to reflect the total, you can notice here, a sample size of 120 is pretty good. You might even want to take it back to 80 here. That's when it starts to get and reflect the whole population. So this straight line over here is called long run proportion, and what that means is it's being quite representative of the whole population. Whereas when we had a smaller sample size, you see that it was not reflecting the whole population at all. So the larger the sample size, the more representative it is of the population, but it is going to cost more.